Okay guys, in this section I will introduce you guys how to use some useful predictor. Mean here predictor, that means the independent variable. Sometimes the time series regression model, they will not just stick with the independent variable that available in the datasets only. But however, we assume that we know there's some kinds of other prediction that we normally can use all the time. For example, like when we do the thing like that, we can easily use other kinds of like the trend data. So you see T here, T mean that with the time increase, the T increase, right? With later the T's will increase. So if the beta 1 will be like a positive relationship, that means the time go up and we have the trend of the data go up. Okay, another dummy variable normally we use for the especially the trading or the sale revenues characteristic will be like for the like weeklies or the seasonal data. Basically they will be all available in the RStudio, so you don't really have to think about the ways you have to clarify it by yourself, but they could be available. Over here to do it, I will use the AUS beer. Remember about this example, right? That should be quarterly Australia beer production from the quarter 1 of 1956 into the quarter 2 of 2010. So they should be available here, and you guys all know about that, right? The quarterly data. The thing will be like I'm going to do the sub window, okay, and I want to use for the window function, all right, and I want to start it from the 1992. If you still remember that, there's some reason behind that, but basically AUS here, if you just clarify it by the auto plot function, all right. So they have a period that not so good with the increasing trend in the data. So I just want to just assume all the data from the 1992, so the data will be more consistent. That's the reason why. Okay, so after when I already do for the AUS beer window, you see they available from the 1992 into 2010 only. I will assign them to be beer2 function. Okay, the beer2 function. And this is the way for me to save the time to just assign for new data. Right now, I'm going to use for the beer2. Okay, sorry, beer2, and then I'm first of all want you guys to just plot it. Okay, plot the time series. Okay, this is very familiar, so I will do it very quick. Okay. So we use auto plot function, right? And later we also want to add in for the X level, right? This will be year, the Y level, all the time. This will be Y lab, and I want to say this will be mega liter. Okay, mega liter. Okay, and if you really want to ask for GC title too, okay, be a production of Australia in mega liter. Okay, so it should be available something like this one, and you already know about that one, right? If you want to check it, I just remind you some kind of check the first field observation. Okay, you had, and then you be to is available here for the first 6 observation, right? You already see it. Now I'm gonna to run a time series regression model of the beer production. Okay, that should be Y values, and with the trend, okay, and season pattern. Okay, that will be the independent variable. Okay, so I already saw I will just go and just that with TSLM, right? TSLM function, and I'm going to just use would be to this would be the data. Okay, so data I will clarify would be a 2, and then other one I use for the function that would be it's be a 2 be a 2 because they just have a one single variable, and then I got it in comparison to the trend. They will be automatically generated plot for the season. Okay, all right, they will be automatically, even when the data just have the one time series vector only, but when we call it like trend, they will automatically understand that we want to add for the trend. That means the time, right? T. Okay, and the seasonal. Okay, the season here we have the season 1 because that's the season pattern here for the season. That's been the quarter 1, quarter 2, right? If that's one will be quarter 1, quarter 2, quarter 3, and quarter 4. This will be dummy variable. Variable. Okay, here would be like -4, -1, that's equal to 3 variable like that. All right. Okay, so I run the data first, and you can see the formula will look like this. Okay, so if this one really true, so B2 will equal to first of all the -0.34 something, right? Time for the T. That means the trend, right? Or if you want to put in a trend, that's be fine. Another one, season 2, that mean -34 time for 66, right? Time for Q2. That means if that's quarter 2 or quarter or not. And then the same thing like season 3, right? -417.82 time for Q3, and blood for 72.79. That means 80 time for the Q4. Okay, that should be the function over here. But however, I'm feel not satisfied with that. Remember, so I will call it fit. I would say the fit of the beer. Okay, fit of the beer model. I will call this one the model, and then I want to see the summary of the model of the fit of beer. Okay, I want to see what will be the function. I had the estimation of the coefficient. That's quite clearly, right? So trend -0.34. That means in average. So for the further the data, let's go with the time. So we had the trend, downward trend. That's for every quarter later. There will kind of a decrease about like 0.34 megaliters of the beer produced. Okay, so that's how the way people call say. Another one like seasonal 2, that means -34.66. Here that's mean like the quarter 2s of the with the kind of like the basement of the quarter 1, that should be the basement. So the quarter 2 when compared to with the quarter 1, that means the quarter 2 normally generates 34.66 megaliter less than quarter 1. The same with the seasonal 3, -17.82. That means in average the production of beer in quarter 3 is 17.82 megaliter less than the quarter 1. And lastly, seasonal 4, that means 72.79. That means in average, the beer production in quarter 4 is 72.80 megaliter more than the quarter 1. That's the way for us to interpret for the coefficient associated with the dummy variable. Okay. Now we check for the highlight the coefficient of the variables. So the trend they are have a p-value smaller than 0.005. That's good. That means they are statistically significant. Seasonal 2, the same. They are less than 0. Even like 0.001. So that means very highly significant, right? Seasonal 3 and seasonal 4, they are all highly significant. The same when we check it for the adjusted odds, where they can jump up to like 91.99. That means almost like 92% of all the variant in the beer production has been explained by the model. And when we check for the F statistic, the p-value is very small, right? It's smaller than 0. That's the same. That means the model is good to use. Okay. All right. But however, now we just not talk about the years. Sorry for the trend data and the seasonal data. I want to go to see it, how they check it. Check the residual, right? The fit value compared to the actual value. Okay, value. All right. And one more time, I go and just use for auto plot. Okay, function for the B2, and I call the series name. That will be actual data. Okay, and then I want to add for another layer, auto layer. Okay, and here I want to use the fitted function to apply for the fit beer model. Okay, so they will generate for all the fittest values from the model, and I want to call the series name will be the fittest value. Okay, right. If that, we just go this way. This will be how it look like. Okay, and all the time like that, I want to just make it a little bit clearer. So I want to export the X level. I wanted to put it in like year. Y level, I want to add it like megaliter. Okay. Okay, and I want to ask for the CC title. Okay, and I want to say the quarterly beer production. Okay, that's how it will look like. One more time, compare the this value and actual value on the scatter plot. Okay, I want to check it. So I use the C combine for all the column. So the first column I call the actual data. Okay, equal to, over here I want to use for the beer too. Okay, of course. And another one, fitted value. Okay, I will want to use this for the apply the fittest function for the fit dark our model actually. Okay, so if I have it, I will have the function like this, combine for all the data, actual data, and the fittest value. You get familiar with that already, right? Now I want to apply for this one, but then I will generate it no longer just the time series, but I want to use for the S data frame. So the data will be transferred into the data frame, and they will be ready to use on the scatter plot. One more time. Okay, so I apply for the scatter plot by ggplot. Alright, and of course the data is available there, so I don't have to, but as testing, x will equal to the actual, okay, data. Alright, y that's equal to fittest value. Okay, alright. Is there any problem? No. And then I plot for the geom point, remember. Okay, if I stop it here, yeah, this will look like this. But however, I want to just change it a little bit now. How we get to do it? So I can just separate all the data into the different color by the quarter. So I have quarter 1, quarter 2, quarter 3, and quarter 4. I want to just color them based on the quarter, different color, right? So I can put in like color will equal to I want to base this on the cycle, okay, the cycles of the BA2. Okay, if I really gonna do it, what happened here? Don't know how to automatically pixel scale for the type of time series. Okay, because this is a time series, so I need to rescale it, and at this time I will use just add factor, okay, for the circle function, and then I click on, let's go and see it. Alright, you see how it's different now, right? Because of the circle, they have the chain. I have already chained for the circle name. Now here will be this based on the quarter. So quarter 1, quarter 2, quarter 4. They are separated by the different color. That's clear, okay? However, as like the data is not so clear, I want to change it a little bit to make it like more appealing. Xlab actual data, right? Plus for the ylab, that should be what I say the fitness value, okay? And then I plot for the GG title, of course. I would say quarterly be a production. Okay. I plot in other types of scope. So I want to create for the scale, okay, quarter. I want to say scale, and then I want to change it for the color, okay. The thing about viewer, okay. This will be how the we people can change for the all the palette, and you see how it look. Palette equal to the color that should be dark, okay, 2, and also I want to change it, name it the viewer, that's mean the CG legend, okay. Name of it I will change it into the quarter, okay. If I gonna just use this, you see like I change it for this one, right? Already. Okay, the same thing we can do it with the guideline. We change for the color of the guide legend. They're the same, but this is different ways of that. Alright, and I want to add in for the AB line too. Remember about that. Want to do it like in the set will equal to 0, and slope will equal to 1. And if that just be clarified like this way, the data look like this. If I want to change for the color, okay, equal to maybe over here I want it just like green, blue, okay. I want it just to be blue, okay. So I change for the color of that one clearly, right? The last one, cross validation, okay. Validation. So cross validation over here I use for the CV function, okay. The CV function can help me to fit for the data of the all the data about the year, okay. And I'm going to check it by what we already run it in the chapter 3 is about in the chapter 5 but in another section. So cross validation we can easily create for the cross validation for the archive keys, information criteria, or the Bayesian correctness archive key information criteria or Bayesian information criteria adjust this elsewhere. That should be the main way for us to clarify about how it would be the best predictor accuracies by all the color. This one, right? Basically on all that's one. So when you have a key or BICs, the thing like that, you will compare between the model, which one has smaller values. That means that have a better fit, and which one have a higher adjustments elsewhere. That means that one have a better model. And thank you so much.